Welcome to Pramod Nainapalli YouTube channel. Today we discuss in continuation of previous topic, that is aromaticity. We have discussed in the previous about aromaticity of benzene and other compounds. But in this particular video, we will discuss about heterocyclic compounds. Aromaticity of heterocyclic compounds. So what is this heterocyclic compounds? Heterocyclic compounds are those compounds in which one or more carbon atoms are replaced by heteroatoms. What are those heteroatoms? So heteroatoms means like oxygen, nitrogen, sulfur, etc. So what is heterocyclic compounds? These are the organic compounds in which one or more carbons of the ring are replaced by the heteroatoms like oxygen, nitrogen, sulfur. So there is no need of much to study about heterocyclic compounds, as we are going to study in pharmaceutical organic chemistry 2, that is 4th semester. So here you have to know only certain type of compounds example for the heterocyclic chemistry. So we will take the examples like pyrrole. This is called as pyrrole. 5-membered ring containing nitrogen is called as pyrrole. 5-membered ring containing oxygen is called as furan. And 5-membered ring containing sulfur is called as thiophene. I have taken 3 different heterocyclic compounds. Now if you see these 3 different heterocyclic compounds, 5-membered ring containing nitrogen means one of the carbon is replaced by nitrogen. Here is carbon, here there is a carbon, and here there is a carbon, here there is a carbon, here there is a carbon. But one carbon is replaced by the nitrogen. That is called as an heterocyclic compounds. This is a pyrrole, this is a furan, and this is a thiophene. Thiophene. So what is a pyrrole means? 5-membered ring containing nitrogen is called as pyrrole. 5-membered ring containing oxygen is called as a furan. 5-membered ring containing sulfur is called as a thiophene. Now we have to discuss this heterocyclic compounds aromaticity. To discuss with the aromaticity, yesterday in previous my video I have set 3 important rules or criteria to tell that the compound is a aromatic or not. What is that first criteria? It must be a compound must be a cyclic planar in nature or planar in structure. Cyclic and planar in structure. Each carbon atoms must possess p orbital and must continuously overlap. Third one, it must follow Huckel's rule. It must follow Huckel's rule. Huckel's Huckel's rule. 4n plus 2 pi electrons. Now if these 3 criteria are fulfilled, then we can say that heterocyclic compounds are aromatic compounds. Now let us discuss one by one. First we take the compound pyrrole. Now generally in the outermost orbital the nitrogen contains 1 pair of electrons. In the outermost shell the paired electrons, oxygen contains 2 pair electrons, and sulfur also contains 2 pair electrons. Okay, now let us discuss according to the rules. We discuss pyrrole. If you see, it is in a planar in structure. Okay, it is in a planar and cyclic in structure. Okay, so first criteria holds good. Second criteria, each carbon must possess p orbital and must continuously overlap. Double bond is there here. One p orbital, other p orbital. All carbon atoms possess p orbitals. And also there is a pair of electrons. Pair of electrons on nitrogen, that also takes a p orbital. Now what happens? There is a continuous overlapping of p orbitals. Yes or no? So each carbon atoms each atoms possess p orbital. Even nitrogen is having a one lone pair of electrons. So it also possesses the p orbital. And there is a continuous overlapping. Yes, second criteria also is holds good. Now third criteria, yesterday we have discussed Huckel's rule, 4n plus 2 pi electrons. How many pi electrons are there? One double bond, two double bond, but nitrogen is also containing one lone pair of electron which help in the sextate formation of this pyrrole. Means how many? Two double bonds and one lone pair. Means two double bonds means 4, 4 plus 2, 6. So 4n is equals to 6 minus 2. It will come 4, n is equals to 4 by 4, n is equals to 1. N is 1. Means it is an integer. It is a integer. N must be a whole number. Okay, if n is an 0, 1, 2, 3, then it follows the Huckel's rule. So n is 1, then it follows the Huckel's rule. So according to the Huckel's rule also this pyrrole will follow. That's why what happens? This pyrrole is an aromatic compound. This pyrrole is aromatic compound. Now let us discuss about furan. So furan is also a cyclic and planar. I will denote with a different marker. First criteria we will examine. It must be cyclic planar. It is a cyclic 5-membered ring containing oxygen. Okay, and it is in a planar. First rule holds good. The second rule, each atoms must contain p orbital. Yes, it contains a p orbital. If you see this, it contains p orbital, double bond p orbitals, and it contains one p orbital, one lone pair of electrons. The other lone pair of electrons are not involved. Only one lone pair of electrons are involved inside the ring. One is outside the ring. They are involved in the bonding. Okay, no, they are not involved in the sextate formation. Only one we consider from the oxygen. Okay, so one lone pair of electrons. Now there is a continuous overlap of each electron with each p orbital. Yes, there is a continuous overlapping of p orbital. Hence, second criteria is also correct. Follows. What is the third criteria? Huckel's rule. Again, two double bond is there. We consider only one lone pair because one lone pair are involved within the ring. One is outside the ring. So within the ring only we will consider that lone pair. So this is also same like 4n plus 2 is equals to how many electron? Two double bond 4 and one pair of electron 6 electrons. So this is also gives n is equals to 1. So and this also follows Huckel's rule, and this criteria also holds good. Therefore finally we can tell it is also a aromatic. It is also aromatic. Now thiophene is a last example. 5-membered ring containing sulfur. It is an heterocyclic compounds. This is also a best example. Here also it is a cyclic planar. Okay, what is it is? It is a cyclic planar. I will denote with the green color. So first criteria holds good. What is the second criteria? Each carbon atom must overlap each other, and also each atom, not only carbon, each atom must overlap. So each lone pair odd electrons overlap each other. Continuously they overlap. And hence the p orbitals are continuously overlap. This also holds good. And again here sulfur contains two lone pair of electrons. One lone pair is inside the ring. We consider only one lone pair of electrons which are inside the ring. There is a two double bonds in the thiophene. 4 plus 2, 6. Again for Huckel's rule, if you go same 4n plus 2 like pyrrole and furan, it gives n is equals to 1. It gives n is equals to 1. So n is equals to 1 is a whole number. It also follows the Huckel's rule. Okay, by this all three criteria we can tell that heterocyclic compounds are aromatic compounds, or they are called as an heteroaromatic compound. Heteroaromatic compound. You don't worry about this particular sem, what are heterocyclic compounds, what their nomenclature. You are going to study in POC 3. So this is what about the aromaticity of heterocyclic compound. Thank you.